So, welcome to this blog review. In case you're not familiar with the format, it's going to be about an hour long, and we'll aim to spend 45 minutes on the actual interview part, and then
Yeah.
5, 10, 15 minutes, whatever it is at the end for feedback, questions you have. In a real interview,
All right.
right? They might do some introduction at the start. They might do some stuff at the end. We're going to skip all that. Just go straight to it. Okay.
Yeah.
All right. So for this problem, Python is your preferred language, right? Just double checking.
Yeah.
Okay.
Yeah.
Okay. Cool. All right. So for this problem, I'm gonna read it out to you, and then you're free to ask any questions. Please feel free to take notes in the code itself, like comments over here.
Okay.
Okay. So for this problem, your input is going to be a list of numbers. All
hmm
right. And I would like you to return at the end the mean, median, and mode.
Sorry, could you repeat that again?
Yeah. So your input is going to be a list of numbers, and I would like
Yeah.
you to, in the end, to return the mean, the median, and the mode.
Sorry, I'm not familiar with like the terms mean, median, and mode. Could you clarify those, please?
No problem. So the mean is a simple average. It's the arithmetic average. The
Okay. Just average.
median
Yeah.
is the number in which half of the values are less than that. I mean, wait. Do you wanna take your notes first?
Yeah.
Okay.
So
So
just this first one is just average, right?
yeah, the
Second one
arithmetic
is
average. All three of these are types of averages, but yes,
okay.
the mean is what most people think of as the average. The
Mm-hmm.
median is
Mm-hmm.
the number from the
Mm-hmm.
list in
Mm-hmm.
which half of the values are less than this number and half of the
Mm-hmm.
values are greater than this number.
Okay. Half is less than this, and then other half is great greater. Okay. So the other way. Okay. Okay. So basically, a number instead of the list that um okay, okay, I think I get it. So half of the list is greater, half of the list is smaller than this number, but this number exists instead of the list, right?
That's correct.
Okay. So the last one is
The last value is the mode. The mode is the most common number.
mode equals most common number. Okay, so could I just repeat the question just to make sure that I understand, please?
For sure.
So I'm given a list of numbers. Is it like a float number, just like int?
They could be floats. They could be anything. They could be integers as well. Yeah, they could be any number.
Okay, just numbers. Would it be an actual like number or like a string
Oh, they will all
with
be number
numbers?
types. Yeah, they would all be in
Okay,
Python. They would all be integers or floats. Yeah,
okay. And I just need to return three values, which is just the average of the numbers. Um, this average might not exist instead of the list. It might, but it might not.
correct.
Median is an actual number that is the middle value, which means that it is the values might be it's like in the middle where there are numbers that are greater and then numbers that are smaller, but it's just like the medium value inside of the list. So this has to exist inside of the numbers list.
Mm-hmm.
And mode is the most common number inside of the numbers list, which is pretty straightforward.
That's right. Yep.
All right. So could I get a minute to think about this question?
Okay. Yeah, that's fine.
And so do I just need to like return like let would that be like a method header or should I just create one like
Yeah, you should yeah, like this is just from CoderPad. Like yeah, you should create a method from that. So you can call you can call the method like get averages or something.
maybe the list of numbers? So you said the list of numbers could be an int or like float. I'm not 100% sure like how to make a method header that has like float and an int. Could you help me with that or would that
Oh yeah.
actually
Well,
make a
in that
matter?
case, it wouldn't really matter. In Python, you can just treat everything as floats. It's going to be fine. So you can just have list of float. and then you would want to return a tuple, right? So you want three values to return. So it'd be a tuple. Well, I mean, don't need a type for that, but basically you want a tuple that contains three values, which are these three over here. Don't worry too much about the types if that's what you're concerned about. The types don't matter.
Okay.
Just go ahead and solve the problem. Yeah, yeah.
For sure. So I think I'll just attack this one by one.
Okay.
So the first one is like pretty straightforward. I think what I could do is just get the sum of the whole list and divide it by the length of the list to get the average.
Okay.
And I could just add that to the tuple. And then for the second one, I think what I could do is, am I allowed to use like sorting functions that are built in Python or no?
You can use sorting. Yep.
So I think what I could do is use the sorting method to sort the list, and what I could do is, sorry, I forgot to clarify this part. So let's say like you're trying to get the median, right? But then like the list that you're giving me was like one or two. Which one should I return or like add to the tuple?
That's a great question. So when the length of the list is even,
Yeah.
you take the simple average of the two middle numbers.
Simple average. What do you mean by the simple average?
Simple average is the arithmetic average, which is 1 plus 2 divided by 2 in this case.
Okay. So median might not actually exist instead of the numbers. So
That's true if
if
the length is even. That's right.
okay, if even, then just okay. So just to clarify, like if it's 3 and 4 here, the length is even. So I would just need to divide these two and get the average of those, then return it, right?
That's right. Yes.
Okay, sounds good. Oh, I see. If even, okay. So sort the list, and what I would do is if the list is even, then I think I could just use like I access those two values right away by doing like divided by 2 or something, length of the divided by 2 and -1, just to access like the index, like those two numbers, and then add those two up and divided by 2. Or if it's like like an odd number, then I could just um, do just access the middle value. So
Okay.
if list is odd, then I would just do like length of the list like divided by 2. And if it's even, then I could do length of the list divided by 2. So for the first index, so it'll be 1, 2, 3, 4, 2. And then the second index will be like length of the list plus like divided by 2 and +1 to access the second one. And we could just add those two up and divide by 2 and add it to the tuple.
Okay.
Would you like me to clarify anything, or?
This is an index, right?
Yeah.
Okay. No, that makes sense. Yeah.
Okay. And for the third one, just most common number. So I think I could just use. Am I allowed to use a counter? Would it be better if I just create my own dictionary?
You can use it for now, but I might ask you
frequency?
to make it yourself.
Okay, so for third one, I think I could just use a counter one, and then pretty sure there's like a built-in function where instead of a counter, you can just use like most common function. But if it doesn't have to be like this, I can just like sort it using like lambda function based on the key values of the counter, and then just return the first index, like the first number of it.
Okay.
So use counter, and sort the list, sort the value, which is the frequency, the counter, and return the the first the first key. Does that sound good to you, or would you like me to clarify any of these?
No, no, that makes sense.
Okay, so I think would it be okay if I start coding it out, or
Yeah, that's fine. Yeah, I think you're good to go.
okay? So I would just return. So first answer would be a tuple. So I'm actually not 100% sure. Like I know what a tuple is, but I'm not sure how to like initialize it at first. Would it be just like this with um like default values, or would it be like is there like a function to create a tuple first?
Yeah, so this would be how you would create a tuple, although
Mhm.
tuples are immutable, so you cannot create them ahead of time.
Oh, okay. So
So in that context, you would need to create the three values separately, and then make them into a tuple to return at the end.
okay. So I think I can just store them using a list at first, and um, and I guess I'll change them at the end to a tuple. Does that sound good to you?
Yeah, that's good.
Okay, so the first one, sum of the whole list divided by the length of the list. Average is equal to sum of the list divided by length of the list, and insert append average. And next one is this one. So list dot sort. Need to first sort it, and if the length of the list is length of the list is even, then we would have to do length of the list. So first index is going to be length of the list divided by 2, and second index would be length of the list, or like first index just plus 1. And just be first index, second index. I'll just add them up and divide it by 2. So insert append first, so list of the first index plus list of the second index, and divided by 2. Um, if it's not even, it's odd. So I think what we could do is 0 plus 3 divided by 2, which is 2 is 1. Okay, we've already sorted it out, so we just do insert the append list of the sort it. If it's odd, then you just that's will be at 2.5, and it truncates. So just to clarify,
Mm-hmm.
I'm not sure if you're allowed to answer this question.
Yeah,
If I do 3 divided by 2, it'll be 1.5, right? But
yeah,
since this is like integer division, I think,
yeah.
it would be just 1, right? Because it truncates towards 0.
That's right. It'll be
Or,
one. Yeah.
okay, that is not the median one. It's plus 2. What if if it's 1, it's 1, then it will be 1 divided by plus 1. Okay. Getting the middle value. Sorry, I'm just thinking of some edge cases.
Yeah, no worries.
List is odd. Length of the list divided by 2. So by 2 is 1. It's 1. Then it would just be 1 divided by... Oh, okay. I think this will work. Sorry, I was just confused on something. Length of the list divided by 2, and enter the middle index. And counter sort the frequency. So counter equals counter of the list. And you have to import them. Is it? Counter and counter. And we would have to get the most common one, which is counter dot sort. Sorry, I'm thinking if I was allowed to call like counter dot sort and just use like key lambda and then like sort it by the values like x dot value, but
Well, a counter is a dictionary type, and dictionary types are not ordered. So you wouldn't be able to call sort on a counter.
okay. So I think what I could do is I could just extract the frequencies from the counter and then sort them, and I would create a loop and sorry, I would just do extract the values from the counter and sort them reversed, and the first value, so first value of the key, after this I would go through the loop. Oh, sorry, not the loop. I would just go through. Oh, sorry, I forgot to clarify this question.
Okay.
What if there's a frequency that are the same?
Could you clarify?
So, what if there's like one, 1, 2, 2? Which one would I return in this case?
For our case, let's just say there is going to be one unique value.
Oh, okay.
Yeah, but just make it simple.
So extract the values from the counter, and I would just go through like the dictionary. So like for like at a like in like counter the items. Oh, I actually thought of like an easier way. So I think what I could do is we're just trying to get like the one that's the most frequency. So I think I could just call like the max function instead of the counter dot values. So like answer dot so most frequency like value is going to be like counter of the max of the counter dot values, which is like the biggest, like the largest number inside of the counter.
What do you mean by
And then,
number?
sorry.
What do you mean by
Oh,
largest number is at the counter?
so counter has like one and then like the frequency of like these numbers, right?
Yep.
So I think what I could do is I just need to return like a value, like a number that has the most frequency, right?
Yes.
So I'll just access it right away through like calling the like the max of the counter, like the values of the counter. So picking the largest number instead of like the counter, like the values instead of the counter, and then accessing the key directly, and adding that to the answer array.
What does counter.values return?
Doesn't that return the the values instead of the counter?
Yes. So what is the maximum of that list? Like use this as your example. Like say this is 4, so it's not a fake example,
Yeah.
right? So what is counter.values?
Counter the values would be like 3 and 4.
Okay. And what's the maximum of that list?
4.
Okay. So then you have this.
Oh, sorry. Okay. Sorry. Um, okay, yeah. Um, frequency. I think okay. Um, I think what I could do is I could just do like max frequency and then just call like max of the counter dot values, and then I would have 4, right? So
Mm-hmm.
this would be 4, and I would do like 4 like key and then frequency in counter dot items, like accessing both of the counters at the same time.
Okay.
If the frequency is equal to like the max frequency that we have, we would just add it to we just add the key to the answer, and then just like break um, to get the key with the maximum frequency.
Okay.
Does it make sense
Okay.
to you, or would you like me to
That yeah, that
clarify
makes
more?
sense.
Okay,
Okay.
so we built the answer like the answer array, and we will need to tuple. So um, would there be like I know that set has like a call it set like this if you're trying to make a list to a set. Does
Yeah.
this work with the tuple also?
Yeah, it does.
Okay.
Okay.
Um, okay.
Do you want to work through an
Uh,
example to make sure you didn't miss anything?
okay, sure. I'll just do like 1, like 2, like 3, 4, 5.
I would
This
recommend
would
an
be
even list.
even one. Okay, 6. Okay, so first would be like sum of the list divided by the length of the list. So length of the list just be 3, 6, um, 10, 15, 21. 21 divided by 2, 3,
21
4,
divided by
5,
6
6,
is 3.5.
3.5. Okay, which is basically like 3 because it truncates, and the average would just be 3,
Do we
which
want to
makes
truncate
sense.
the average though?
Oh, oh, okay, I see. So I think in that case we would just use like a float division.
Okay.
So this would just stay as 3.5
Okay.
and 6, and I would attach that 3.5 to answer. So right now answer um, is 3.5, and I'm going to sort the list. Let's say it was like it's already sorted, so it'll be the same. And
Okay.
if the length is even, so we will enter this part where we have first index, so length of the list, so 6 divided by 2, which is 3. So we're going 0, 2, 3. Oh, okay. See problem. Zero, 1, 2, 3. Just be 3 and then -1. Sorry, could I just get a moment to think about like this
Yeah,
edge
sure.
case? Okay, so if it's 2, 3, 4, 4 divided by 2 is equal to 2. So 0, 1, 2. The second one has to be -1. So this one. Okay. If it's like 1 and 2, if it's 1 and 2, then just 1. It's 1. Okay. I think I made a mistake here.
Okay.
The first index is 3, so 0, 1, 2, 3. In this case, the second index will be like accessing 5, which would be wrong. So I think I just had to change to -1.
Okay.
So in this case, I'll be accessing like 4 and 3. Would you like me to change the variable name, or
No, the name's
is that
fine.
okay? Okay. So this one would just be like 3 minus 1, which is 2. So in this case, answer is going to be list of the first one. So wait, sorry, I'll just go like list of the 3 plus list of the it's like 3 plus 4, right? So 7 divided by 2, which is like 3.5, but it's truncates. Oh, wait, for this one also, does it? I think we would have to keep a like float value. We can't just keep an integer value.
Yeah.
So I think this would have to be also float division. So it would just be like 3.5.
Okay.
So answer is 3.5 and 3.5. So we skipped this part because it wasn't odd. And this one, like the counter, it would be 1, 1, 2, 1. It's 1. And like the frequencies of all of them are the same. As you said before, you said like let's consider that we have a one with the most frequency.
Yeah.
Would it be okay if I just changed like the 5 to like 6? So 6 has 2.
That's fine. Yeah, that's fine.
Okay. So maximum frequency is 2 right now because we're getting the values. So counter the values would just be like 1, 1, 1, 1, 2. And maximum of these list would be like 2. And we're gonna go through like the counter, like the items, where we just go through each of them together, like key and frequency, key and frequency, key and frequency. And if we find the frequency that is equal to what we have right now, which is 2, we would append answer to 6. So answer will now be like, and then 6. And then at the end, this will be converted to tuple. So I would just return like this.
Yeah. Yeah, that's fine. Okay, cool. Let's talk briefly about the time and space complexity of your solution here.
Okay, so for the time complexity, I believe that average sum like list like sorting algorithm like sorting function dominates all of them, so it will be um, n log n. I
Okay.
think in Python sorting takes like n log n time complexity,
Mm-hmm.
and in terms of the space complexity, answer is just 3, but we're storing the counter, the list. So we're storing all of the, we're going through all of the numbers. So it would just be O of n.
Okay. All right. Okay. Sounds good. Um, Now, I wanted to ask a little bit about. So, I mean, sorting is obviously one thing, right? But one thing I also noticed that you're actually iterating through the list 3 times, right? So, for example, over here, you have an iteration,
Yes.
right? Um, well, this is not an iteration, but this over here is an iteration as well. Over here.
Yeah.
Oh, I think he instantiated it. Wait, what's your input? Oh, it's called list. Okay, that's fine. So over here, you also have an iteration,
Yeah.
right? I'm wondering if there's a way for you to avoid doing that twice and just instead iterate through the list once. Do you think you can modify your code to do that?
Sure, I could try. Would I just do it like at the end of here, or would
Yeah,
I
so what
need
I
to
would
continue?
recommend is I recommend you keep this untouched. Just copy that, just comment that out, and then you just continue editing at the bottom. So you can change anything you want in this copied function, and the goal is to iterate only through the list once. And of
Hmm.
course, your sort method that we can leave this part unchanged. That's fine.
Okay. Um, okay, sounds good. So to do only one length of the list. Okay. Sum and the counter. So I think what we could do is I'll just like delete this. I'll just make my own counter. Wait, sorry. Counter would equal just like dictionary, and sorry, I'll just put this at the top actually. And I would just do like for um average. Okay, so I'll just do like um list sum is equal to 0, just adding all of the numbers there. And I would do for num in the nums list, I'm going to do um, if that num already exists instead of the counter, then I would just do this, sorry, counter of the num. I would just add 1 to the frequency, and every time I loop through the list, I'm just going to add the current number to the sum over um, like list sum, and if it does not exist, then I would just create a counter of the num, which is equal to 1. In this case, we're iterating only 1, but we're getting the sum and the counter.
Okay. Yep.
And to get the average, we would just do list sum divided by um, length of the list. We could actually create another variable called like length, which is like equal to length of the list, and then we use a length of list like quite often here, so we could just replace it
Mm-hmm.
with like length for these.
Okay. No, that's fine. I think it's fine to leave it that way.
Okay.
Yeah.
And then yeah, so this would stay the same, but for max frequency, um, I'm just wondering when we do like max of the counter dot values, right? Is that
Hmm.
also iterating the values also once? Because this is like also iterating through the counter.
Yes, that is also iterating. Yeah, so that actually would have been 3 times. Okay, I was right the first time.
Okay. So I think what we could do with the max frequency is like max frequency would equal 0,
Hmm.
and when we add like a new thing to the counter, like add one to the counter that already exists, we could do if the counter of the num is if that's greater than the max frequency that we have, max frequency would equal the counter of the num to keep the max frequency as we're iterating through.
Hmm. Okay.
And yeah, this would just stay the stay the same for key frequency encounters. Oh, okay. And then I don't think we even need to iterate it through this actually. We could just answer like counter of the um, max frequency because that's the wait. Sorry. We actually need to iterate through because max frequency is the value. I thought of it as the key. I thought of it as the key.
But can we not iterate though? Like our goal here is to not iterate.
Okay. For key and frequency kind of. If
When you set the max frequency here, what else do you have?
oh, okay. Um, just do like max frequency like number. Um, and I'll just do like default number as like 0. But when we set the max frequency, I think we could also do like max frequency num is equal to um, like the num because that is the number with the max frequency.
Mm-hmm.
Yeah, and then at the end, we wouldn't have to loop over, and we could do answer this at append this at the end.
Cool. 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 Does this change the time or space complexity at all?
I think we always like consider like the worst case.
Mm-hmm.
Um, I'm not like 100% sure, but from my like
Yeah.
from my guess, like I don't think it would change like the worst case because it was O of n time. Um, wait, yeah, like the like time complexity is um, n log n because this one just dominates all of them,
Mm-hmm.
even in the first solution. Um,
Yep.
Even for like space complexity, we're still storing like all of the numbers inside of the n list, like the list. So it would stay as O of one. Oh, sorry, O of n.
Okay. Yeah. So in other words, the time complexity didn't change, even though we are only iterating through the list once. Well, by ourselves. This over here is doing some iteration too, but okay, cool. That's fine. Um, all right. So we got a couple minutes left. So what I would like us to do is I would like us to begin thinking about a second problem, but I don't expect us to be able to finish it. But I want to see what your intuition about it is. I want to see what kind of ideas you have about this problem. Okay. So this problem, I'm gonna copy it down to the bottom. Um, so here's the problem. Please have a read and let me know what your thoughts are.
Every close bracket is. So it's only containing parentheses, and you're just trying to see if the order of the parentheses is valid.
That's right.
Okay, so open bracket must be closed at the same time. Brackets. So would this be a valid
Yep.
like string? Okay. I think what I would do is I would just I would need to create a map where sorry I don't think I'm just gonna code. I'm just gonna like
That's fine.
comment
Yeah.
it out. So I'm just going to create like a map where we have like the um sorry, like the closing parentheses as like the key, and then like opening parentheses as like the value, and then do the same for like all of the other like different types of like the brackets. And I'm going to like iterate through the string, and if the if if the if the char that we're currently at right now while we're iterating over
Mm-hmm.
is the key, if it's the key of the no if it's the values of the counter, so like the opening brackets, then we would append it to a stack. So I'm going to create a stack, um, and if the current string that we're at is opening, append it to the stack. So, and we would just keep doing that while we're iterating over. And if it's not a stack, if the chart is closing, we would have to check um, first is the stack empty. If it is, then are we returning like Boolean value or
Like it's
okay,
return true if and only if the string is valid. Basically,
okay.
yeah.
So like if the stack is so while we're iterating through, if we see that's one if we see one that's closing, um, then we would check if the stack is empty, that means that it doesn't have the corresponding closing bracket. So we would just return false. And if we have another case would be if we have like if the current char is like not equal to uh, it's closing, then if the current chart is not equal to the like the map of the wait sorry map of the so if it's closing, then if the last like the last element of the stack is not equal to the oh wait so if iterating through the string, if the character is opening, you append it to the stack. So sorry, I'm just like going over like a simple
Okay.
example. If it's opening, then we stack. Okay, so if the last element of the stack is not equal to the stack empty, so um, so map of the current char, which would be like the opening bracket, then it would just return false. And after we iterate over, if we have an empty stack, then we return true because that means that we found all of our like matches. If it's not empty, then there's like still leftover like opening brackets, which means that it's not valid.
That makes. I want to just quickly, I know we're a bit low on time. But I just want to quickly dive into this one. What's the stack dot pop mean? Like, did you just mean the top element, or did you actually mean to like pop it off?
We would have to pop it off because every time we're going over it, we would have to, like, if we found a match, then we would just like iterate over. Um,
Yeah.
so we would have to pop the stack to go to to check the next element instead of this the stack.
Yeah. Okay,
Like
that makes sense.
we
Yeah.
would have to delete this. Yeah.
Yeah. So if it's open, you always append no matter what kind of bracket it is, as you were saying,
Yeah.
right? And if it's closing, you need to check. Well, obviously, if you're closing with nothing that's empty, then it's immediately returned false. Of course.
Yeah.
But if there is something, then you have to check that it this we were saying, like this map over here, right?
Yeah.
Like it corresponds to the right character.
Yeah.
Um, why do we like? Do we need a map here? Is there a reason you chose to use a map? Is there
Um, I just thought that was like the most like intuitive way that I could think of.
Okay. Okay, that's fine.
Uh,
Yeah. It's gonna work. I just was curious about why you used a map. Okay, that's cool. And then, do you have any intuition about the time and space complexity for the solution?
Um, the time would of course just be going over all of the string, so it would just be like linear, so like O of n,
Okay,
and
and space.
the space complexity would be we're storing only like I'm not 100% sure with like the time complexity of like the I'm sorry, it's the space complexity of the like the three types of brackets, but
Okay.
um it wouldn't it would just be like constant because um sorry, I'm not actually 100% sure with the space
Yeah. Well,
complexity.
your map wouldn't be using your map would be constant space because you only have three pairs of parentheses.
Yeah.
But
Yeah.
your stack is going to be
Oh,
using more
sorry.
than most of the space.
Yeah. Like the worst case would just be we would only have like the like string with only opening brackets, so that would just be storing all of them, so it would be O of n time also.
Yeah. Okay. Okay, cool. Let's talk about it. So that concludes the mock. I want to just quickly ask you, how did you feel about this? And then of course
Um,
we'll go to the feedback question, etc. But I want to just just get a pulse check. How do you feel about this so far?
I feel like I could have done it better. I was a little nervous. So
Okay. Yeah,
I
yeah, yeah.
think yeah, I made some mistakes, but um, yeah, I feel like I could have done better, but it is what it is, you know.
Well, what do you feel like were the biggest mistakes?
I think the biggest mistake was like not fully. I was making a mistake using like accessing like a counter with a value, not with a key,
Yeah.
and um, I think I could have clarified the edge cases at the start, like asking if they're only like even or odd length of lists, uh, and I think also at like the start I wasn't familiar with like the like tuple part, so
Yeah.
yeah, I think I just need more practice with these.
Okay. And how and like in terms of solution confidence, like how confident are you in your solution? Like I guess you have two here, right? Like how do you feel about it? Like do you feel like that those are optimal? Do you feel like they're not optimal? Like how
Oh,
do you feel about them?
I don't think they're optimal.
Okay.
Um, I just like chose like the most like like the way that made the most sense to me and easier to like code it up.
Yeah.
Um, but I feel like there should definitely be a more optimal way to solve this.
Which let's talk about each of the solutions individually. Like the first one about the averages.
Yeah.
Where do you feel like that one wasn't optimal? This is like an intuition check. Like there's not necessarily a right answer here, but like where do you feel like that your first solution was not optimal?
I think like sorting the list itself, um,
Do you know, like, is it the case where it's like, okay, there's a better solution but it's too difficult to code, or it's like you don't know there's a better solution, but you think that there must be one?
I think it's the second
Okay.
choice, second
Okay,
option.
that's a good
Yeah.
intuition. We'll get to that. How about the second? How about
Yeah.
the parentheses question? Do you feel like your solution here was optimal?
Um. Oh, space.
Because like I just want to understand exactly where we are with the strengths and weaknesses. Like a lot of the times, a lot of people kind of do these solutions, and it's like they don't know like what strategy they're taking on, right? Like, are you going to go for optimal solution, or are you going to go for like a safer one but easier to code? Like in your case, I mean, we didn't do coding here, right? But in your case, like, do you think this is optimal,
Um.
right? Like you said, in space, in time. That's what you said, right?
Yeah. Yeah. Constant stack. We need a stack in the first place.
It's a
Um.
bit of a like it's a bit of a tough one because especially if you're like newer to Leetcode and stuff, it's hard to be able to tell and distinguish, right?
Yeah.
But we'll go over that. Okay, so,
Yeah.
uh,
I'm
so
actually not sure about the second one.
okay, yeah, we'll talk about that. All right, cool. So, um, overall, pretty good performance today. Right, we got a couple easier questions, but I thought you handled them fairly well, especially with the follow ups. I think most of the extra kind of performance you can gain is not really through algorithmic practice, although of course you would get more there. But right now it would be from having a better like approach and system for solving problems. Because one of the things today was that you were sort of just winging it in terms of like how you would approach a problem. I think a bit of a system would help you a lot more. For example, there were a couple of things I would have expected you to do. Let's take the first problem, right? The first one is I would expected the examples to come out immediately, right? So in terms of
Oh.
examples, I mean, like especially because you kind of you didn't realize that there was a difference in the median case, between the even and the odd length list, right? Until you started the problem, right? Similarly with the mode, right? You didn't realize that there could be multiple modes going on, right? So those are kind of things which you can't really get caught out after you start implementing it. Like that's a bit of a bad sign, right? So
Hmm.
you want to be able to catch those early on as soon as possible, and the easiest way to do that is by just writing out a couple examples at the start, right? So
Okay.
rule of thumb for this one is, when your input is a list, your output is like a couple values, right? There's a lot of combinations that can go on over there. I would
Hmm.
recommend at least like two examples there, like two pretty full examples, just to make sure you kind of got some basics covered, right? As you do
Hmm.
more problems, you have a better intuition about what sort of edge cases there might be, what sort of you know numbers you might want to check, right? But rule of thumb, if you got some complex case like this going on, you definitely want to have like two cases at least, right? Okay,
Okay.
so that's gonna help you out with the start, help you like at least formulate how you want to think about it. The second
Hmm.
thing is when you have the examples on the page and you work through them, you could already start formulating how you want to actually process it algorithmically, right? And by having an example there, you can actually really use it to help you determine the algorithm,
Hmm.
right? An example of where that would have really helped is a more advanced student here would have been able to find the one pass solution pretty early on, right? This is not like difficult code to write the one pass, like the single pass solution. It's not difficult code. In
Yeah.
fact, most of the problems that have these sort of problems will actually require a one pass solution, right? I mean,
Yeah.
like you said, asymptotically it's the same, but in the real world it's not the same, right? It's twice as slow, two passes, right? Or three passes, three times as slow, right? Um,
Yeah.
so having that example that's going to really help you. Now, a second place that
Hmm.
example would have helped you here is with the actual numbers, right? Like for example, with the actual numbers, you would have realized that for the average, or what you call the average, the mean here, you shouldn't be using the integer division, right? Like that shouldn't be using integer division. That should just be using regular division,
Yeah.
right? Stuff like that are kind of more basic cases that you would definitely be able to work around, or to prevent if you had an example, because then you would just check in with the interviewer. Hey, do you agree the answer here should be 3.5? Etc. Right?
Yeah.
So
Yeah.
that's like a strategy thing. Like that's not about your skill in coding. That's just a strategy thing. So that using that better strategy would help you more with preventing those kind of silly issues. Okay.
Yeah.
Um, I will quickly touch on this problem while we're here, and your intuition is quite good. So there is a more optimal way to solve the median case. Now, once you start, I don't know if you've done like algorithms class yet, but typically speaking, you'll learn this algorithm once you're learning about quicksort. So, part of
Oh.
quicksort's algorithm is that the reason quicksort is efficient is because it is able to partition the array effectively. And the way it partitions an array is with an algorithm called quick select. Okay,
Hmm.
so you're gonna go home and you're gonna, or you're probably home already. So you're gonna go back after this, and then you're gonna go learn about this algorithm called median of medians, or in other words, quick select. It's the same. It's quick select's the version used in quicksort, but I mean you find it under two names, quick select or median of medians. That is a linear time algorithm to find the median in an unsorted list. Okay. Now that is a fairly niche algorithm, which I don't want you to go and memorize. Okay. But what you do need to know is you do need to know that these algorithms exist, and it is
Hmm.
major points to at least say so. Right. So
Okay.
for example, you're doing this thing and say, hey, I know that there's an algorithm called quick select. We could be getting this in linear time. I don't know how to implement that right now, so I'm gonna go with this more basic one, but we can revisit that later if you want. Right. So calling that out tells me that you're very clear in your head. Oh, you know something better exists, but you also recognize your limitation. You don't know how to code that, and so we're gonna go something basic. Right. So it's a it's an explicit trade off. Right.
Hmm.
And so if you can call it out, that's very good. All right.
Okay.
But I won't harp on that. You just go learn it yourself later. All right.
Okay.
Okay. So last thing about the first problem I'll say is the counter. Right. The counter. It's good that you know it, but I feel like there's a couple of gaps here with your knowledge. Right with the counter.
Yeah. Yeah.
Um, one thing I'll say off the bat is that at the start you actually you called out this function called counter.most common.
Yeah.
Um, that is actually correct. Like you could have used that, but you know, if you use that, then I would have said, okay, let's implement it ourselves, right? But
Yeah.
I
Yeah.
think it's good that you call it out, right? What I didn't expect here is that there was a bit of a struggle here with the key and value pairs, right? Like you're trying to
Yeah.
use the value to find the key. Like that's usually not going to be very common. Now I will say something is this doesn't apply to this problem, but if you do find that you really do need to use the value to find a key, what you're looking for in that case is what's called like a bidirectional map, right? And so, this don't do it for
Oh.
this problem, but for some problems you do
Yeah.
need that. That is available. Like you can do that, right? And if you're not allowed to use the ones in certain libraries and stuff, you can always roll it yourself, right? Like just declare a second map and just make the other way around, right? So there are ways to do it. Wouldn't help you in this problem, but there are ways to do it, right? So just be aware. These little things you kind of are expected to get better with as you progress. Okay.
Yeah. Sense. Yeah.
Um, yeah. Parentheses question here. I think you did actually very well in this one. This is the optimal solution, and the reason you should be able to tell that um, is because of your time complexity, time and space complexity. Okay. So
Hmm.
the time complexity here you know is optimal because to process to determine if a list is valid, you do need to cycle through the entire list, right? Or
Oh
in other
yeah.
words, you need to cycle through a linear portion of the list. So like technically speaking, you don't need to cycle through. Like your best case is that all like the first half of the list are all open parentheses, right? Then you know it can't be possible because you can't close it in time, right? So, but that's a linear optimization. It doesn't actually save you time complexity. You still need to cycle through half plus one of the list, right? So
Hmm.
from that you can tell, okay, the time complexity must be at best linear, right? And then you're saying, okay, you're using a stack. Well, you're using a stack to be able to track the state of your opening parentheses, right? So in that case, for this problem, because there are many types of parentheses, and the ordering of the parentheses matters, you can't use them like a number. You have to actually have the order of these parentheses. So a stack
Yeah.
is needed, and so the linear space complexity is also optimal,
Okay.
right? So that kind of stuff is something which which you will get better with as you practice. And
Hmm.
a really important thing about that is, let's say you did what you did here, right? And you talk about time and space, and then when you're thinking about it, you should realize, oh, actually, this is going to be quite optimal. This is actually like I shouldn't spend time trying to optimize this. I should just try to focus on implementing it because this is going to be as good as it gets, right? So
Okay.
these little bits of strategy are what you could develop and get really good at, and these kind of things add up over time. right? So
Okay.
I think you have a really good foundation here with what you've done. But obviously, as you get more practice, strategy wise, lead code wise, etc., you're going to do a lot better. But
Yeah.
today, I think you still did quite well.
Thank you.
Any questions on your part?
Um, so like I've actually never had like an interview where I actually had to code stuff up. Like of course I've done some like mock interviews with like friends or like other people just asking for like some mocks, but like generally like when you do an actual like coding implementation interview, um, like is it the best like what's like the best order of like approaching the question? Is there like a general like rule?
Well, so I mean, do you mean like strategy, like what I said earlier about that strategy, or do you mean
Not like
something else
strategies,
about
but like
approach?
yeah. So like first you would actually like of course read the question and clarify the questions
Yeah,
with the interviewer,
yeah.
and would you always like start like do at least like a one example to like make sure you fully understand the input and the output and confirm it with the interviewer?
I would say that is always the correct thing to do. And what I mean by that is that it's correct to do about 90% of the time. Uh, but the reason you should always do that is because you know it's an insurance policy, right? Like for this question, it's really quite a simple question. But if you get any of the arithmetic wrong, it means your entire approach is wrong, right? So something that's an insurance against making a really stupid mistake or misunderstanding what a term means or do something else that's like dumb. So I would say that's always a right thing to do for these kind of problems because if it's an easy problem, you can do the example really quickly. You can just bang it out, right? So I would say approach wise, it's basically always a good thing to do an example first to be able to confirm the number or solution is correct, and then to be able to use the example to work through your approach and algorithm.
Okay.
And this will be
So
quite
like
common for questions which are a bit more difficult. And
mhm.
then it can be ambiguous. Like it's either that the question itself is ambiguous, like part of the test is they want to see if you can identify ambiguity, and then the
Mhm.
other part of it is that the algorithm is difficult, and so you want to have a decent example to be able to think through, like a coding component. Go ahead.
Okay. Um, so like let's say like usually when the interview gives you like 45 minutes, is it usually like for like easy ones, it's usually like two questions expected to finish in 45, right?
That would depend on the company. I would say in basically all interviews that are 45/1 hour long, you are expected to do two problems, and that would be either two problems that are like completely different problems, or like one problem plus one follow up, like a difficult follow up. Yeah.
Okay. In terms of that, like let's say it's like an hour interview long and you're supposed to do like two questions, so 30 minutes on each questions. Like how long would you actually like spend understanding and clarifying the examples or like writing a pseudocode with the interviewer before actually diving into the implementation?
So that's a strategy question. The approach you take there depends on two things. The first thing is how much of a chance do you have? Okay, so here's how you should think about it. In an average case, you should spend at least probably like 3 minutes, like working through an example, like working through an example, running through an algorithm, going through some like thinking about how you want to structure your solution, right? That's like a base case, and then you have like 20 minutes maybe to like polish it up, right, etc. Right? Where that wouldn't apply is, for example, if you know your chances in interview is not going to be well. Like for example, if you know the questions will be harder than what you're able to do, in that case, you basically need to take a risk. All right. So first, I'm not saying you should do this all the time, okay? But I'm telling you, like realistically speaking, you will be able to tell, not rarely, like somewhat often, when you're doing well interview, like in terms of the rounds in a company, and when you're not doing too well. When you're doing well at a company, you should hedge your bets. Don't do anything risky, right? And then spend the time on the example. Spend the time working through like a building a solution up. Like start with the basic solution, build it up really quickly, right? See what you can do there, right? Now,
Mhm.
at some interviews, you know your chances aren't good. I'm gonna say it straight, okay? So this is a difficult company, and you need to take a risk. And so what a risk means in this case is you do a very bare bones basic example, and you give yourself as much time as possible to come up with the optimal solution, right? And this would also mean, for example, This would also mean you need to like spend more time up front not doing the brute force solution, but just trying to straight go into something optimal, right? And depending on the person, depending on you, you might find it's easier to go from nothing to optimal with a comprehensive example. Some people like myself, I find it easier to go from nothing into optimal with a bare bones example, right? So that will really depend on your strategy. But depending, so right, so the approach you take depends on the situation you're in, and depends on all the surrounding factors, right? So I can't really say like I did not to give you direct guidance on what to do, but what I will say is that it is very typical, and I would recommend spending about 3 minutes on coming up with examples and working through them.
Okay. Sounds good.
Okay. Anything else, questions wise?
Um, no, I think it was a really good practice. Yeah, thank you for this mock interview.
No problem. All right. Take care.
Yeah.